So in this video, we're going to solve one sample problem of fluid flow measurement of fluid mechanics. So a 75 millimeter diameter orifice discharge 0.023 cubic meter per second of liquid under a head of 2.90 meter. The diameter of the jet at the vena contracta is found by calipering to be 66.25 millimeter. So A. Calculate the coefficient of discharge, and B. Calculate the coefficient of contraction, and C. Compute the coefficient of velocity. We have the given data. A discharge of 0.23 cubic meter per second, a total head of 2.90 meters, the diameter of the jet at vena contracta, which is 66.25 millimeter, and the orifice diameter, which is 75 millimeter. So now we're going to proceed with our solution. First, we're going to calculate the coefficient of discharge using the equation where discharge equals to the coefficient of discharge multiplied by the area times the square root of 2 multiplied by the acceleration due to gravity times the total head. Since we already have the discharge, which is 0.023 cubic meter per second, equals to the coefficient of discharge times the area, which is pi over 4 multiply 75 millimeter times 1 meter over 1000 millimeter squared. So we're going to convert 75 millimeter, the diameter of orifice, into meter, and multiply by the square root of 2 times 9.81 meter per second squared multiply 2.90 meter. So solving it into our calculator, we get 0.69. So next, we are going to calculate the coefficient of contraction using the equation of coefficient of contraction equals the area 2 over the area 1. So our area 2 is pi over 4 multiplied by 66.25 millimeter squared. So this is the diameter of the jet at the vena contracta. And our area 1 is pi over 4 multiplied by the diameter of the orifice, which is 75 millimeter squared. So using our calculator, so the coefficient of our contraction is 0.78. And lastly, we're going to compute the coefficient of velocity. So the equation that we're going to use, coefficient of discharge equals to the coefficient of contraction multiplied by the coefficient of velocity. Since we already have the coefficient of discharge, which is 0.69, and the coefficient of contraction, which is 0.78. So 0.69 equals 0.78 multiplied by the coefficient of velocity. We get the coefficient of velocity of 0.885.